Hey, hello, geometry friends and fans alike. We are in the third lesson of chapter 2, and we're going to be learning here about another type of reasoning. 2.1 was on inductive reasoning using patterns, and now we have deductive reasoning. So take note of that. There's two different types, and they sound very similar. So first we had inductive, and now we have deductive. So let's jump right into the definitions and the questions for homework 2.3. Okay, and that's our first definition, deductive reasoning. This is using logic to draw conclusions from facts, definitions, and properties. So unlike inductive reasoning, which again, we looked at a lot of number patterns, or if you look at routines, what you would expect to happen based on previous observations, that's inductive reasoning. Deductive reasoning doesn't necessarily require like a history or a background to follow a pattern. It's just using either facts, definitions, or properties. So first thing I'll note here is it's not based on patterns. That contrasts it from inductive reasoning. Second is, just like for an example, I was thinking about this. I was encouraging all of you to use these videos to help you with your homework, especially some of you who scored low on the recent quizzes and tests. And so that's because I was drawing the conclusion that many of you were not watching the videos. My basis for that one would be looking at your grades, also looking at the number of views of this on the class YouTube page, and I can see that there's nowhere near the many views as there are students in the class, and so therefore I can conclude that not everyone is watching the videos. And so that would be an example of deductive reasoning, and I'll just kind of summarize that, throwing a little bit of shade at you or encouragement, but not all students. Well, actually, let's say it this way. Geometry YouTube page has fewer views than students in the class. So that's kind of my setup. So therefore, not all students are watching the videos. Okay, and so that's a conclusion that you can draw based on not patterns, but based on a fact or a definition or a property. The fact is, in this case, a fact that what the YouTube view counts are for the geometry videos. The other reason it could take the same conclusion if I wanted to make it more inductive, just for a point of contrast, would be I've taught geometry for 10 years, and when making videos, most often kids rarely want to watch the videos because they just want to get through their homework as quickly as possible, and they're less interested in actually learning the content. That would be an inductive conclusion based on my previous pattern of observations in terms of students' willingness to watch videos. So notice the difference, one based on patterns, but this lesson 2.3 on using facts, definitions, and properties. And looking secondly at this thing called the law of detachment, specifically using what we talked about in 2.2, and that is conditional statements. We learned about if-then statements in 2.2, where if P is true, then Q is a conclusion, is also true. If P, then Q. And so what the law of detachment says is if P, first of all, it has to have a conditional statement. So if P and Q and P is true, so in other words, the hypothesis is true, then deductive reasoning tells us then Q is true. So in other words, when we do those conditional statements from 2.2, you are using not inductive pattern-based reasoning, but you are using deductive reasoning. Okay. Just making sure we're recording the right thing, hopefully. Jesus' name. All right, so let's go ahead and do an example of using deductive reasoning. We'll say we'll just say if you watch the geometry videos, then your grade will improve. And you can debate that, but that's just go ahead is an if-then conditional statement. So then to use the law of detachment, you have to first of all have an if P and Q. So I've written that. Then I would have to say, let's see, who can we go with? Let's just say Josh watched the geometry. Sorry, I'm running out of room here. Videos. Okay, so if we set up the if-then statement, if you watch the geometry videos, then your grade will improve. And then you can say that P is true, if, in this case for Josh watched the geometry videos, then what can we conclude? The law of detachment using deductive reasoning says we could conclude that Josh's grade will improve. And so that's taking what we learned in 2.2, an if-then statement, and recognizing that that is a use of deductive reasoning. Okay, but again, it's key. You have to, first of all, have an if P then Q relationship, and you have to know that P is in fact true. It kind of triggers the conditional statement. Now, the law of syllogism expands upon this, and it says it is a combining of multiple conditional statements to draw a single conclusion. Okay, so for example, let's just build off of what we've been working with. Let's go with right here. If you watch I'm going to try to abbreviate a little bit here. Be clear in your sentences. Geometry videos, then grades will improve. I'd be a little more clear if I had more space. That's why you should use as much as possible. Then say I go ahead and make another statement. Say if your grades improve, then you will get in and out. All right, a little reward or something. Okay, so what the law of syllogism says, if you take two different conditional statements, but they're linked. So in other words, here we have a common, we have the conclusion here is the hypothesis here, where your grade improving is the conclusion on one, but it's also the hypothesis of another, then that links these two. And I could write through the law of syllogism, I could say if, my room is tight here, didn't leave myself enough room. If you watch geometry videos, then you will get in and out. Because they're combined now. Because the watching the videos leads to improving grades, and then improving grades leads to the in and out. And so law of syllogism is like a bridge that links these. Symbolically, and I'll have to just put this down here, it's like you have P, you have this statement P if P then Q, and you have a statement that says Q if Q then R. The law of syllogism then states, therefore, if P then R. And so again, it's like a bridge where again you have that common statement that is the conclusion on one side and the hypothesis on another. Therefore, you can jump from P all the way to R. So it's kind of like knocking down dominoes. And you can do this just with two, or it could even be more extensive with three or more conditional statements that all link together. So that's the law of syllogism. So let's take a look at our questions for 2.3. Question number 1, real tricky one. Which law is like a bridge between two conditionals? Well, we just talked about it. Deductive reasoning is the use drawing conclusions using logic from facts, definitions, and properties. The law of detachment is using a conditional statement in order to draw a deductive conclusion, but it was this law of syllogism. So you're jumping right, just like you see illustrated there. P, if P then Q, if Q then R, therefore P, if P then R. So that's just looking for you to identify that as the law of syllogism or syllogism. You want to have fun. Okay, so the law of syllogism. That's all you really have to do for that one. Number 2, write a set of conditionals to which you can apply the law of syllogism. All right, so I just did that up here, but let's go ahead and do another one. How about if you like movies, then you are a Star Wars fan. Notice I'm just writing conditionals here. I'm not actually evaluating the truth value of these. That's independent of at least just setting them up, because you might, of course, disagree with this and have a counterexample. And then I could write another one, again, taking my conclusion and making it the hypothesis for my next conditional statement. If you are a Star Wars fan, may the force be with you. Whoops. Then you and Mr. Mefford, that's me, are BFFs, best friends forever. All right. So there we go. Then we take that's notice. So now we've created a bridge where, in completing the first conditional statement, we're going to trigger all the way down to the final conclusion. If you like the movies, then you and Mr. Mefford are BFFs. Okay, best friends forever. Happy to have you. Okay, because, and we can go ahead and write that. It's kind of slow. If you like movies, you can pretty much skip over the second statement because they're linked. Then you and Mr. Mefford must be, whoops, this is my contact, Mr. Went too fast. Mefford are best friends forever. Okay, that's the law of syllogism. And make sure everything has to be in the same order. It has to be that second that first conclusion with that second hypothesis, and you can then jump from just one to 3. All right, let's go ahead and do number 3. According to the law of detachment, if a hypothesis is true, does that mean the conclusion is true? If a conclusion is true, does that mean the hypothesis is true? If the hypothesis is not true, does that mean the conclusion is true? Okay, so let's take these one at a time. So according to the law of detachment, if a hypothesis, if P, then Q. And they're saying P is true. Okay, let's just take any one of these. If you are a Star Wars fan, then you and Mr. Mefford are BFFs forever. So if that's your if then statement, and they tell you you are a Star Wars fan, let's see, Tanya is a Star Wars fan, then me and Tanya are best friends forever. So this is true. This is, what does it actually say? According to the law of detachment, but does that mean that the hypothesis is true? Yes, it does. That's the definition. If you go look back up and look at the law of detachment, that's the definition of the law of detachment. If P, then Q, and P is true, Q has to be true. Okay, so then the next one asks, though, if a conclusion is true, so if say you have this exact same thing and it says if P then Q, and it tells you Q is true. So let's just use that silly example I was just saying. Tanya and Mr. Mefford are best friends forever. Does that mean that Tanya likes movies? In other words, just because Q is true, the conclusion, does that mean the first thing is true? No, not necessarily. Maybe we're best friends forever because we both love geometry, or we both enjoy hablamos el español. So this would be no. So be careful of that. If they say if P then Q and they say, hey, Q is true, don't assume that means P is true. That's incorrect. That's invalid logic. And so we'd have to say no. There could be other reasons for Q being true besides the P. So if she is a Star Wars fan, then yes, we have to be best friends forever. If we're best friends forever, it doesn't necessarily mean it's because of the initial hypothesis. There could be other reasons. And the third one, it says, if the hypothesis is not true, whoops. If you have if P, then Q, and Tony, I think you're going to like the conclusion of this one. If you're watching, you should be. If P, then Q, and it says P is false. So in other words, not P. So if you like Star Wars, then you and Mr. Mefford are best friends forever. Tanya does not like Star Wars. Can you conclude that me and Tanya are not best friends forever? No, you cannot. Because it simply says, if you are a Star Wars fan, we're for sure going to be friends. But it doesn't say those are the only people I'm best friends forever with. So if they say that P is not true, do not say that Q also cannot be true. So that is also no. That is not the case. Okay? Because just it says if P is true, then Q is true. Saying P, just saying no. Well, that perfect example. I just said it. If just because she's not a Star Wars fan doesn't mean we can't some other way become best friends forever based on the logic of that statement. So be careful. The only way the law of detachment works is if you say if P and Q and they tell you Q is true, then it triggers Q. I mean, if P is true, then it triggers Q. If they tell you Q is true, that doesn't tell you anything about P. If they tell you P is false, that doesn't mean that Q is necessarily false. So be careful about that. It's be a little counterintuitive. Alrighty, check out the exercise video if you want my help walking through some of your exercises. All right, talk to you soon.